In this video, I'm going to talk about the cerebellum, which sounds a lot like the cerebrum, but it's a different part of the brain. So if we look at the brain over here from the front, we have the cerebrum on top with the right and the left cerebral hemispheres, and we have the brainstem underneath that connecting to the spinal cord. And then behind the brainstem and below the cerebrum is the cerebellum. Let me just color that in here. And you can't see it that well from the front because it's behind the brainstem. But if we come over here to the back, if we're looking at the back of the brain, the cerebrum is on top. Here would be the left cerebral hemisphere, and here would be the right cerebral hemisphere. And here you can see more of the cerebellum because it's behind the brainstem. So now we can't see much of the brainstem because the cerebellum is covering it up. And the cerebellum is also divided into hemispheres. Here would be the left cerebellar hemisphere, and here's the right cerebellar hemisphere. And then we can just see the brainstem and coming into the spinal cord down here, but we've cut off the spinal cord. Now the cerebellum does a number of different functions, but probably the most obvious thing that it does is it coordinates movement. Coordinates movement. And it's pretty neat how it does this, how it works with the other motor structures in the nervous system to coordinate movements, because the cerebellum really smooths out movements and it makes them more accurate. Like if you're trying to touch something with your finger, the cerebellum plays a big role in your accuracy and in your finger touching the object that you're shooting for. And there's kind of three parts to how information travels into and out of the cerebellum to let it do its job of coordinating movements. So let me write three little marks here, and we'll quickly go over the three parts. And the first thing the cerebellum needs to do is it needs to get information about the motor plan. Motor plan. And the motor plan involves which muscles need to contract and at what intensity and what duration. How strongly to contract those muscles and for how long to contract those muscles to do some kind of movement that you want to do. And don't worry about the anatomy of this stuff for this introductory discussion of the cerebellum, but in other videos we can go into more detail on how the motor plan is developed up in areas of the cerebral hemisphere that plan movements. And then to make those movements happen, upper motor neurons up here in the cerebrum send their axons down through the cerebrum and the brainstem, and they cross over, and don't worry about the anatomy of this. But then they talk to lower motor neurons. For example, some lower motor neurons in the upper part of the spinal cord here that'll send information out, let's say to a muscles in the arm that'll tell the arm to move in a certain direction, to do some kind of movement with the arm that you want to do. And that actually makes the movement happen. But while all that is going on, while the movement is actually being executed by the upper motor neurons and the lower motor neurons and the muscles that they're synapsing on, information about that motor plan is also being sent to the cerebellum. So there's another pathway that sends information down through the cerebrum and into the brainstem, and then that information passes over and into the cerebellum so that the cerebellum is aware of the motor plan. So now that the cerebellum is aware of what the motor plan is, now it wants to know how the movement is actually going, so that it receives position sense information, and this is position sense information that isn't reaching consciousness. We're not aware of it. It's just going to the cerebellum, so that there are receptors involved in position sense, like the muscle spindles that sense stretch of skeletal muscles out here in the body. And then somatosensory neurons bring that information back into, say, the spinal cord, if we're talking about a movement of the arm. And then once that information enters the spinal cord, there are tracks that'll carry that information up into the brainstem and then into the cerebellum. So that now the cerebellum knows what the motor plan was, and it can compare that to the movement that's actually occurring by looking at this position sense information. And it can see if the movement's occurring according to plan, or if corrections are necessary, if the movement needs to be fixed somehow to make it smoother and more accurate. And usually that is the case. There does need to be some kind of correction to get the movement to match the motor plan. So then the cerebellum needs to send feedback back to the motor areas, back to the motor areas of the cerebrum, the areas that came up with the motor plan in the first place, to try to correct that movement while it's occurring. So that feedback information will travel from the cerebellum through the brainstem and into parts of the cerebrum, and then back to the motor areas of the cerebral cortex. And then they can use that feedback information from the cerebellum to fix the movement, to make it smoother and more accurate by changing the activity of the upper motor neurons. That'll change the activity of the lower motor neurons. That'll change the activity of the skeletal muscles that are performing the movement. So again, don't worry about the actual anatomy and the pathways now at this introductory level, but this is kind of the bird's eye view of the way information flows in and out of the cerebellum to help coordinate movements. And without getting too deep into the anatomy of the cerebellum, one little detail about the way the cerebellum is set up in general is that the kind of middle part of the cerebellum here, toward the midline, tends to mostly coordinate kind of movements involving the middle of the body, I like to think of, and in particular walking. So the muscles of the trunk and the legs involved in walking got a lot of coordination from the middle of the cerebellum here, while the part of the cerebellum more on the side here, farther over to the side of the cerebellar hemisphere, is more involved in coordinating movements of the limbs. So coordinating movements of the arms and the legs when they're being used kind of individually. That involves a lot of activity of the cerebellum over on the side here. And then a bunch of different parts of the cerebellum coordinate movements involved in speech. Let me just draw a little mouth here saying hi, because we actually have lots of little muscles that have to move in our lips and tongue and throat to speak properly and to enunciate. And if the cerebellum isn't functioning properly, we can have trouble coordinating those and trouble enunciating. And the cerebellum, parts of the cerebellum are also very involved in moving our eyes around. And these are not very good drawings of eyes, but the movements of the eyes to look where we want to look depend on functions of the cerebellum that kind of coordinate those muscles that move the eyes. So there's a lot more details to the cerebellum, but I'll stop here because I just kind of want to introduce where the cerebellum is and kind of its major function in coordinating movements and the different types of information it uses to accomplish that function.